Hey folks, welcome back. Wanted to go over with you how to compare two groups of individuals, of samples. This is called a t-test, and we often will want to see if the interventions or the initiatives that we are putting forward as managers, are they having the desired effect? And if so, how can we demonstrate that? So let's go ahead and take an example here. In this first example, we are trying to figure out if our customer service effectiveness training has that been a useful investment in company resources here. So we have two groups of people. We have a group of 14 people who have gone through the training, and we have 16 people who have not gone through the training, and these are their customer service rating scores over, let's say, the last quarter. The average from all of the respondents. Maybe you got this through a survey or somehow some sort of way of rating them that people can evaluate them by. So now we have two groups. We have a control group, again, no training, and then a training group that actually has gone through the customer service training here. So we have this, and we're trying to figure out if this has been a worthwhile investment. So one of the first things you want to do is just compare the averages. So I'm going to go ahead and click on here, and we're going to press equal sign, average, oops, and then highlight the whole column there. I'll close the quantity, and the average is about 6. Okay, I'll move over, and I can just copy the same equation over. Note that if these are blank here, it's not going to impact the calculation one way or the other. If those were zeros there, it would, but they're blank, so that's kind of ignored. So let's put these in the same number of significant figures. So we have, for the control group, we have an average score of 6. And for the training group, we've had a slightly higher score of 6.36. Now, just looking at the averages, you might think that this has been an effective way of spending money. However, let's go ahead and become a bit more rigorous here. The question is whether or not this is just a statistical fluke instead of random chance, or do we think that there's a high degree of certainty that our training actually has caused the difference in these scores. So let's keep that in mind here. If you recall some of the videos that we've posted here about how these scores should be normally distributed, so they are in a bell curve shape here. And if you take a certain number of people from that distribution, the average might be 6. And if you take another sample of individuals, maybe the score is 6.36. The question is, are those two distributions the same, or do we have evidence to believe that those two groups belong to differently located normal curves? We assume that we without having any information, any tests done, we have to assume that there's been no effect, and it's only when we have cause to believe there's a change has occurred is it then we actually suggest that this actually made a difference between the groups. So, all right, so we have the averages here. The first thing we want to do is, again, compare the means, and Excel has a fantastic tool to do this. So go to the data page. If you aren't familiar with this, you don't have this in front of you, you can there is a command in one of the videos about how to bring out the data analysis tool pack. So you can go up here to data analysis. This is by default not installed on Excel, but it's very easy to enable it. So now here we have the list of the analysis tools, And we're going to look for t-test, and there's several choices here. Paired samples is a way to test if an individual or if a group of people having gone through some sort of a change or an intervention has that resulted in a change from what you were before. So that's not what we have here. We have two distinct groups who are doing different things. So this would not be paired means. The other options here are two tests with equal variance assumed and two tests with unequal variance assumed. Not a whole lot of difference for our purposes between these two, but just for the heck of it, we'll go ahead and use the unequal variance as assumption. This is just a more general case, so it's probably a better choice in terms of being more globally applicable. So we'll press OK. So now we have this is the menu bring up for the variable 1, variable 2. So for variable 1 will be the control group. We're going to highlight all those instances and close that. And now variable 2 is going to be the training group here. We're going to highlight all those. Okay, the hypothesized mean difference. We assume that there's no difference, so the hypothesis mean is going to be 0. Because only if that hypothesis is wrong would we expect there to be a difference between these groups, and therefore we can demonstrate that we have an effective training program. So output, we'll go ahead and just pick this random cell as the top corner of our results, and we'll press OK. And presto, we have a whole bunch of interesting numbers come here right away. Okay, so we have a mean of 6 and a mean of 6.36, the same ones we have down here. We have a variance also here and number of observations. Again, 16 people in the control group, 14 in the training group. Hypothesis mean difference is 0. We assume that the groups are the same. Now here's where we get to the real McCoy here. T-stat, this basically is a measure of how different these groups are. And below that we have P1 tail and P2 tail, as well as the critical t-values for each. So what does this tell you? Well, if you recall some of the videos I had pointed you toward, p-values are the probability of what results comes from a random selection in the sample. We often use a p-value of 0.05, which means that there is a 5% chance that the results that we found came from a random selection of data. The concern, of course, is that it's possible that 1 in 20 instances could actually result in that outcome, but it's unlikely, and we have generally arrived at that opinion that 5% is a good indicator whether something is a real effect or simply a result of random chance. Now, 5% is somewhat arbitrary, and a lot of people debate whether or not 5% is the right number or not, but for our purposes, we'll assume that. Keep in mind that sometimes, for your purposes, if a p of 0.1 of 10% could be enough for you to justify to management that what you're doing is probably working. But obviously, the smaller that p-value is, the more likely you can convince someone that what you're doing is on the right track. Okay, so that's the first part about p-value. The second thing to concern about is this a one-tail or a two-tail effect. So usually when we're discussing differences between means, we want to know if those two distributions are on the same bell curve. So in that case, if one set of means is higher or lower to a great enough extent, that would be a reason to think that they're different means. However, for a one-tail test, you would assume that if you see an effect, it's probably going to go in one direction, and this is based upon whatever your question is. If the question is, does the training produce a difference in how these two groups perform, that would be a two-tail test, because it could be a positive or negative effect. It would still be answer the question. But if you are presuming that the training would improve some score, then that would be a one-tail effect, and that's how you figure out whether or not you're using the one-tail or two-tail statistics here. So in this case, we're trying to improve customer service. So the one-tail p-value is probably the appropriate one. So we look at the p-value here, and this number, these p-values are in you should present them as a percentage. So here we have 0.332. That is basically 33%. So in 33% of the cases, 1 in 3 samples, would you expect to find this particular value. 1 in 3 is not very convincing to anybody, because it's the chances of it being random effect is a substantial amount. If that number got down to 0.05 or less, then that would be considered a strong support that what you're doing has made a definitive change in the outcomes we are seeing here. So I would say from this data that the customer service training has not demonstrated to me that it has resulted in an increase in scores. So that's the first example to look through. Let's look at another example. Okay. Now for this one, we're going to go ahead and see if we go through a training, how effective is the training the day of. So we have a pre-test and a post-test training effectiveness. So we have a certain number of attendees to the training. They take a test at the beginning, and they take the exact same test later on to see if our scores have improved. So in this case, again, we'll start off by just taking an average. And we'll highlight all these. Okay. All right, so in this case, I'm going to go ahead and just reduce the precision a little bit so the numbers are reasonable. So we see here that prior to the training, the scores were about 27.8 as an average, and after they were at 31.7. So there's been some increase according to these numbers here, but the question is whether or not we think this could have happened randomly. So in this case, we have the same subjects taking the exact same test over and over again. So this would be a paired sample approach. So we'll go again to data analysis, data, and we'll go do t-test paired to sample. Okay. We have the B4 through B19, and for variable 2, we're going to go ahead and highlight this whole thing here. And again, we're going to assume that there's no change, and we'll see whether or not we have a significant effect or not. Okay, so here we get the results again here for you. And in this case, okay, we got the average here and the variance here. The number of observations is the same. Obviously, if these are not the same, we actually couldn't even perform this analysis if we didn't have the same number of subjects, because you can't take a retest of someone who had not done it before, or if you don't take the post-test, then that person would not be a part of the analysis for the paired subjects approach. Okay, so our t-stat here is a minus 3.9. Again, we're looking for a one-tail effect because we're expecting to see an improvement in scores here. The p-value of the one-tail distribution is 0.00065. So this is substantially smaller than 5%. So we can definitely suggest that based upon the data we have in front of us, is that our training effectiveness has been effective, and that it means that what we're doing here is having an impact, and that is good justification to allow you to at least to show the people who are in charge of your management that it's having an impact, and that's helpful. So we're going to have for an assignment comparing using one of these tools, and I'll let you decide which one that's appropriate. We're going to have someone test the effectiveness of a trainer after some evaluations. There's a bit more of backstory behind it, which would help inform your decision making, but hopefully these tools will be helpful for you to solve that problem. In the meantime, I thank you much for your time and attention. Hope this has been helpful, and I'll see you in the next video. Take care.